Hello, everyone. You are all welcome to our first session in physics. So in today's class, we are going to start with the first topic in accordance with Jamb syllabus. So we start with measurement and units. To start with, what is measurement? Measurement is the process of observing and recording collected data using specific tools and instruments in the field of science, especially in physics. So it involves the use of measuring instruments such as chemical balance, spring balance, meter rule, caliper, micrometer screw gauge, clock, and thermometer, to mention but few. To obtain accurate measurement, that is the essence of what? Of using a measuring instrument to obtain accurate measurement. So at the end of today's class, we should be able to identify the unit of length, mass, time, volume, area, density, and what have you. Also identify various measuring instruments. Should be able to differentiate between fundamental physical quantity and derived physical quantity, and deduce the unit of derived physical quantities. So that's our target. Starting with measurement of mass. Mass is said to be the quantity of matter contained in a body. It is a fundamental scalar quantity. What is scalar quantity? Those quantity that has magnitude, that is size, but no direction. While vector quantity are those that have both magnitude and direction. So mass is measured in kilograms or gram. So the SI unit of mass is kilogram, with the instrument known as chemical balance or beam balance. So the instrument for measuring mass is chemical balance or beam balance. In terms of properties, mass is constant from place to place. So unlike weight, we are going to discuss about weight that varies from place to place. So mass is constant. So it is very important to have accurate measurement because it is essential in numerous scientific experiments and analysis, research studies across every field. Is that taken? Next is weight. Weight refers to the force produced when a mass is in a gravitational field, right? And it is a derived vector quantity, and the unit is Newton. That is the SI unit. We can get the derived unit by combining by referring to the relationship between mass and weight, which we will get to. So the instrument we use in measuring weight is spring balance. These are some of the questions that can come in your objectives. Spring balance is used for measuring weight, while beam balance or chemical balance is for measuring mass. So in terms of property, weight varies from place to place due to differences in a gravitational pull. So, and we have a relationship, as I said, between mass and weight. So weight, W, is equal to mass times acceleration due to gravity. So mass is measured in kilogram. Acceleration due to gravity is measured in meter per second squared. Is that clear? So this is the derived unit of weight, while Newton is the SI unit of weight. Length. Length is just like the distance between 2 points, right? Or the gap between 2 points, just like distance, the gap between 2 points. Length is a fundamental quantity measured in meter. We use instruments such as tape rule to take length, meter rule, caliper, vernier caliper, and micrometer screw gauge. All are used to take a length. Are we getting it now? So accurate and consistent length measurements are very essential for ensuring precision and reliability in various scientific fields. So that is for length. Measurement of time. Time is said to be that in which event is distinguishable, referencing to before and after. So time is also a fundamental physical quantity measured in seconds. we use instruments such as stopwatch or clock to measure time accurately. So time is very important. Precise time measurements are very important in various scientific experiments, research studies, and everyday application across different fields. Is that taken now? Then fundamental and derived quantity. We have basically 7 fundamental quantities, which are length, mass, time, electric current. We have temperature. Yes, measure in Kelvin. We have mole, or amount of substance, call it amount of substance, and the unit is mole, M-O-L. Then we have luminous intensity. We have luminous intensity measured in candela, CD. So these are the fundamental physical quantity. The derived physical quantity cannot stand on its own. It is gotten from the combination of 2 or more fundamental quantities, right? For instance, area is equal to length times breadth. Length, breadth, they are all fundamental quantity. And the derived unit is a meter square, gotten from the length, unit of length, which is meter, unit of breadth, which is meter, meter square, meter times meter gives us meter square. While density, rho, is gotten from the ratio of mass and volume. Mass per unit volume is equal to density. So the derived unit here is kilogram all over meter cube as the volume. So we can write it as kilogram per meter cube, or kilogram per meter cube in this format. Also, speed is equal to distance all over time. So distance over time, and speed is a scalar quantity in the sense that it has magnitude but no direction. So the derived unit is meter per second. Velocity is a vector quantity which is equal to displacement all over time. And the derived unit also is a meter per second. Are we getting it? We have other derived quantities. For instance, force. Force is a derived quantity gotten from mass times acceleration, right? Just like weight, mass times acceleration to gravity, this one is mass times linear acceleration. So the derived unit here is kilogram meter per second squared. Meter per second squared is the derived unit of acceleration. Acceleration is a vector quantity, and it's also a derived physical quantity. But the SI unit of force is Newton. Also, energy. Energy is obtained from force and distance. So, let's, for instance, we have potential energy, which is equal to mgh. So, potential energy is also a form of what? Derived physical quantity. Being it kinetic energy or what have you, they are derived physical quantity. Power, for instance, is equal to work done all over time taken. So work is measured in what? In joule, and time is measured in second. So we can have a derived unit of power to be joule per second, while the SI unit is a watt. The SI unit of power is watt. Are we getting it? So this is how we get our derived. We have various types of different types of derived physical quantities, right? So all you have to know is that derived physical quantity are gotten from combination of 2 or more fundamental physical quantity, while fundamental quantity stand on its own, right? I hope this is taken. Okay, now we move to measurement of length. How do we measure length? For instance, in school lab, we make use of, we measure length with a meter rule, calipers, or Vernier calipers, and micrometer screw gauge. Now, the meter rules is graduated in centimeter and millimeters. The smallest graduation of the meter rule is 1 millimeter, or 0.1 centimeter. This is known as reading accuracy. And measurement can be estimated up to half of this smallest graduation, which is going to give us 0.5 mm or 0.01 centimeter. So when you are taking your measurement, you have what is known as estimated uncertainty. When I take a length of 10 meter, because of a probability of human error, I'll say, okay, 10 plus or minus 0.05 centimeter or 0.5 millimeter, known as what? Estimated uncertainty. So when taking reading, there are some error associated with taking reading from meter rule or any other measuring instrument. So for meter rule, we call it error due to parallax. In order to avoid this error, what do? You make sure that you look vertically down on the marking instead of slant, right? Instead of slant reading, we look vertically down on the marking point that we are reading. Is that taken now? So take note of this. Error due to parallax. How to avoid it is to look what? Vertically down on the marking. I hope I'm communicating. Okay. So this is how we should look at the meter rule while taking reading. The next is calipers. Calipers are used to measure length on a solid object that are in a cylindrical form. For instance, we have something like this. So in order to measure this, the diameter of this cylindrical rod, what you do is you mount the two legs of this caliper. On touching the surface, you transfer it down to the meter rule as it is here in the diagram. So the distance, the difference between 3, it is in 3 and 5. Now you take the difference between 5 and 3, which will give you 2. Shows that the diameter of this object is what? 2 centimeter. This is how to use what? This type of caliper. We have another one commonly used in industries known as vernier calipers. This can measure length more accurately than meter rule, especially if the things needed to be measured is cylindrical. To measure length to the nearest 0.1 mm, e.g., thickness of a meter rule, the internal and external diameter of a tube, or the diameter of a rod, we use vernier caliper. Please take note of all this because you'll be asked on which material can we use vernier caliper to measure accurately. 1, the thickness of meter rule. 2, the internal and external diameter of a tube or the diameter of a rod. We use what? Vernier calipers. And the reading accuracy of vernier caliper is 0.1 mm or 0.01 centimeter, meaning that it can measure up to smallest value of 0.01 centimeter. Anything smaller than 0.01 centimeter, you will not get accuracy using a vernier calipers. I hope I'm communicating. Now, take for instance, this is a typical vernier caliper. Here is for internal diameter, while here is for external diameter of an instrument. And anything from here, you see all this, we call it main scale. Main scale. While this smaller one is known as the vernier scale. So when taking reading, we are going to add the main scale plus the vernier scale to give you the total reading. Please take note of this. Let's take reading for this. We have this. We want to read the value. I hope you can see it clearly now. So when taking reading, you take from 0 point here. Here's from 0. Now, this is your main scale. You first of all look at your main scale. From here, just before getting to the vernier scale, you stop. Now, you count from 0 to where it stops. Here I have, if it's in centimeter, I'll have 1 centimeter, 2 centimeter, 2.1, 2.2. If it is in millimeter, I have 10 millimeter, 20 millimeter, 21, 22 millimeter. Let's work in millimeter. I have 22 millimeter. My main scale is equal to 22 millimeter. Now, for me to get my vernier scale, I'll be looking at a point where any line on the vernier scale is on the same straight line with another line on the main scale. That is where a line on the vernier scale is on the same straight line with another line on the main scale. We call it point of coincidence. So we are looking for a point of coincidence now. If you start from here, that this line here is not in coincidence with any line on the main scale. This one now is not in coincidence with any line on the main scale. The same thing with this one. But if you look at this one here, you can testify that there's what? That's a coincidence. Let me use red marker. You can testify that this line up here is on the same straight line with this line down here. So a line on the main scale is on the same straight line with a line on the vernier scale. That is where our reading will stop on the vernier scale. Remember that we said that accuracy of vernier caliper is 0.1 millimeter or 0.01 centimeter. So here we are working with millimeter. So my vernier scale will be equal to each of these will be 0.1, 0.2, 0.3, 0.4 mm, right? So I'm going to have, since this is where the coincidence occur, so I'll stop here. That is 1, 0.1, 0.2, 0.3, 0.4. So my vernier scale is 0.4 millimeter. Therefore, my total reading now is equal to main scale plus vernier scale, which will be equal to 22 plus 0.4 millimeter to give us 22.4 millimeter. So this is how to read your vernier scale, vernier caliper. I hope we got it. So I will leave you with this one as a class activity to do to test your understanding, right? To test your understanding. The next is micrometer screw gauge. For accurate measurement of steel, smaller lengths, such as what? Diameter of a wire, the diameter of a small ball, e.g. a pendulum bob, or the thickness of a piece of paper. Thickness of piece of paper, we use micrometer screw gauge. These are also very important because some question will ask in objective, which of these following can be measured using micrometer screw gauge? And some of option and one of this one might be about among the options. So we use micrometer screw gauge to measure the diameter of a wire, the diameter of a small ball, or the thickness of a piece of paper. Remember the other one, vernier caliper, thickness of what? Of meter rule, and so on. So the reading accuracy of micrometer screw gauge is 0.01 millimeter or 0.001 centimeter. Now we are going to look at this one again. Here, you make sure that the object you want to measure its diameter is in contact with the spindle and the anvil of what? Of the micrometer screw gauge. The moment it is in contact, you are going to hear the ratchet. Ratchet will even make a sound showing that it has been in contact. So your target will be the main scale and the vernier scale. Here is the main scale and here is the vernier scale, just like what you have in a vernier caliper. So now let's know how to take the reading for the micrometer screw gauge. So I can see. So I believe you can see it better now. So we have something like this. We have something like this. Now, to take your reading here, just what we did in a vernier caliper, you have your main scale. Main scale is all this. These are your main scale. These are your main scale. So take note, these are your main scale. So now you start from 0, 5, 6, 7. Now, after 7, you see something here, right? You see something here. So that is half of it, that is 0.5. So you're going to have 5, 6, 7, that is 7.5 mm. So I'm going to have 7.5 mm as my main scale. This we are reading in what? In millimeter. We are reading in what? Millimeter. So we have 7.5 millimeter. Now, for us to, get our main vernier scale reading, we are looking for a point of coincidence again. I don't need to tell you point of coincidence. You're supposed to understand what I mean point of coincidence. So we are looking for at a point where any line here, any line in this vernier scale is in coincidence with any line here, with this particular line. Remember, this is horizontal. So all these other are vertical. So we are looking for a point where any of this line, this line are also horizontal, is in the same straight line with this line that holds the graduation of the main scale. So, and the only place we have that is here, which is 25. And this is going to be, that is 0.25. Remember the accuracy, which is 0.01 mm or 0.001 centimeter. So that is why you're having 0.25 what? Millimeter. So having gotten the vernier scale, so vernier scale is equal to 0.25 millimeter. So your final reading now is equal to main scale plus vernier scale, which is equal to 7.5 plus 0.25. That will give us, what is it? 7.75 millimeter. 7.75 millimeter as your final reading. I hope this is understood. So that is about a micrometer screw gauge. So I will leave this one for you to do as class activity. So this is very simple. I hope if you actually follow what I've just done, this one is just like a very simple like ABC for you to do, and some many other ones that you can also handle. So the next is measurement of volume. We can measure regular shapes, can measure irregular solid shape. If it is for regular shape, all you need to do is to take the length, the breadth, and the height. It will give you the volume for a regular object. But for irregular objects like stone or any irregular shape, we use Eureka and a measuring cylinder. So what you do is that you fill the Eureka to brim. So, and you suspend that measuring, and you suspend that object you want to measure, the irregular object you want to measure, you suspend it and insert it inside the Eureka. So the water will now overflow due to amount or the volume displaced by the object you inserted. So now your volume of that object is the volume of water displaced by the object. So that is what will be collected here. So you now take it to measuring cylinder to measure the volume of the irregular object. Is that taken now? So in WAEC, there's a WAEC question that asks to explain how to measure irregular shape. It's as simple as this. This is the setup. The amount of volume of water displaced by the irregular shape is equal to the volume of the of the shape. You take it to the measuring cylinder and get the exact volume of that object. So other instruments are burette, measuring cylinder, volumetric flask, and pipette. All these are used in taking the volume of object. I hope this is clear. So just like what we discussed in taking reading using meter rule, it is also applicable to what? To measuring cylinder and any other measuring instrument, that you ensure that you look vertically instead of what? Slant. And if it is volume, take cognizance of what? Of the meniscus of this volume, of this liquid. That is where you take your reading. Not here, but the meniscus. Are we together? So this is where you're going to stop in today's class. The class is now open now for question and answer session. If there's anything you don't comprehend, let us deal with it for better understanding. Thank you.